Man, I just can't figure out these Lewis structures.
I wish there was a sign!
Did someone say they need some help?
Wow! It's Captain Chemistry!
What are we working on here today?
Well, you know, I just can't figure out these Lewis structures.
That seems like something I can handle. Alright, Jace. The first step in drawing our Lewis structures is that we're going to find the total number of valence electrons. Alright, to start off, we're going to use a simple H2O molecule. And our first step is we're going to find how many valence electrons are in each element using our periodic table. Hey, we're going to need a periodic table. Alright, so as we can see in our periodic table, hydrogen is in group 1, meaning it'll have 1 valence electron. But our subscript tells us that there are 2 hydrogens, meaning we're going to have to multiply that by 2. And then our oxygen, as we can see, is in group 6, meaning it's going to have 6 valence electrons. When we add that together, 1 times 2 plus 6, we get 8 valence electrons.
Wow! You're so smart!
Hey, let's try one more. For this next one, we're going to use hydroxide, which is simply oxygen, hydrogen with a negative. Oxygen, as we already know, is in column 6, meaning it's going to have 6 valence electrons, whereas hydrogen is in column 1, meaning it's only going to have 1 valence electrons. But the trick with this one is that we have a negative, meaning we're going to have to add 1 more valence electron, putting our final number at 8 valence electrons. Okay, so step 2 is going to be putting the least electronegative atom in the center of our Lewis structure. How do we know which one is the least electronegative though? Well, looking at our periodic table, we know that fluorine is the most electronegative in the whole periodic table, which means that as we move away from fluorine, we know that our atoms are getting less electronegative. For example, since we know nitrogen is further away from fluorine than oxygen, we know that nitrogen will be less electronegative compared to oxygen. As an example, we can use NaCl2. As we can see from our periodic table, Na is going to be much further away than Cl to fluorine, meaning that when we write our Lewis structure, we're going to put Na right in the center there, and since we have 2 Cl's, we know we're going to put Cl's on our sides. 2 important steps to this part of our Lewis structure building though. Remember that if there are only 2 atoms, such as HCl, we're not going to have to worry about which one's in the center, considering we only have 2 atoms. As well, if we have hydrogen in our equation, for example in HCl2, no matter what, hydrogen always goes on the outside of a Lewis structure.
Oh, so hydrogen is an exception, huh?
That's right. Step 4 is going to be getting 8 valence electrons on our outside atom. 2 important rules to remember for this step are the octet rule and the duet rule. The octet rule states that any atom in a Lewis structure needs 8 valence electrons in order to be satisfied. But the duet rule is an exception, which states that hydrogen specifically only needs 2 valence electrons to be satisfied. So for example, if we did HCl, we would know that hydrogen, once we do our Lewis structure, only is going to need 2 valence electrons in order to be satisfied, whereas Cl is going to need 8 because of the octet rule, and hydrogen only needs 2 because of the duet rule. So if we look at our periodic table, we know that hydrogen is in the first column, meaning it gives 1 valence electron, whereas chlorine is in the 7th, meaning it gives 7 valence electrons, and altogether that gives 8 valence electrons.
So the octet rule applies to every single atom except for hydrogen?
You got it! Now once we make our Lewis structure, we know that hydrogen, once we connect it to Cl with our line, since this line is worth 2 valence electrons, we know that hydrogen is already satisfied because of the duet rule. But we know that chlorine is going to need 6 more valence electrons in order to be satisfied because it already has 2 because of this bond line. So we give it 6 more valence electrons in order to be satisfied with the octet rule. And when we add up all these valence electrons, we can figure out that it is equivalent to 8, meaning that this Lewis structure is complete. Step 5 is going to introduce multiple bonds. Multiple bonds can include double bonds or triple bonds. Multiple bonds are needed in a Lewis structure if all of the electrons have been used but not all the atoms are satisfied. Well, we're going to use CO2 as an example. As we know, using our first step, we're going to find all the valence electrons. Carbon in our fourth column has 4 valence electrons, whereas our oxygen in the sixth column is going to have 6 valence electrons. But as we know, since our subscript tells us that there's 2 oxygens, we're going to have to multiply 6 times 2, giving us 12 valence electrons for our oxygen. And altogether, that's going to give us 16 valence electrons. Using our next step, we're going to find out that carbon is going to be our center atom because on the periodic table, it is further away from fluorine than oxygen. So we put carbon in our center with our 2 oxygen atoms on the sides with a bond to connect them. But with this Lewis structure, if we did it normally, we would run out of our 16 valence electrons, but not all of the atoms would be satisfied. So for this Lewis structure, we're going to have to use a double bond on both of our oxygen atoms. This way, our carbon is already satisfied, but our oxygens still need 4 more valence electrons. So we give them each 4 more in order to satisfy them. Now, as we can see, all of our electrons are satisfied, and all our valence electrons add up to 16. But for CO2, you can actually do this in another way using a triple bond. So if we set up our Lewis structure again with our 2 oxygens and our carbon in the middle, we can actually connect one of our oxygens with a triple bond and then the other oxygen with just a single bond. This way, our carbon is already satisfied, and this oxygen is only going to need 2 valence electrons extra in order to satisfy it, whereas this oxygen is going to need 6 more, which will still satisfy all of these with 8 valence electrons, and if we add up all of these valence electrons, we will find that it is equivalent to 16.
Oh, so if I ever run out of electrons, I can always rely on multiple bonds.
Spot on! Now, let's review all 5 steps to form a Lewis structure. Step 1 was to find the total number of valence electrons in our molecule. Step 2 was to find the least electronegative atom in the molecule and put that in the center of our Lewis structure. Moving to step 3, then we form a chemical bond using 2 valence electrons, which we use in the form of a line. Step 4 was to satisfy all the remaining atoms using the octet rule and the duet rule. And then finally, step 5 was to figure out how to use multiple bonds if needed. Alright, Jace, does this make sense to you?
Totally, Captain. Can you explain some more chemistry to me?
Sorry, Jace, I got a call.